Alright, in this video we discuss about inverse function for quadratic. Okay, for quadratic function, first we will show how the quadratic is not one-to-one function. Okay, and then next, from not one-to-one function, how we restrict the domain for the quadratic so that the quadratic we will have an inverse. Okay, so after we restricted domain, then we'll find the inverse for each restricted domain. Then after we find the inverse, we will sketch the graph for the quadratic and its inverse on the same axis for each restricted domain. Alright, so look at the quadratic function given here. So actually this question we take from the lecture notes, the last examples in lecture notes regarding inverse function. Right, so for the quadratic, remember you have to find out its minimum point. So actually the function is positive here. Okay, so you have to find out the minimum point. So in order to find the minimum point, we have to do the completing the square. So completing the square for this quadratic would be this one. Okay, so what will happen here is the value of b here is actually negative b, include the negative. So the value of b here, we will divide by 2, so it will become 1. So here 1 is actually b over 2. And we follow the same negative sign here. Okay. And then, don't forget to put the square, the bracket and the square after that. Okay. And then outside here, it must be negative over here. Okay. So the negative is the mass. And then 1 here is actually refers to this b over 2 also, but we have to square the value of b over 2. However, in this case, the value of b over 2 is 1. So since 1 also represent the b over 2 squared, so the value is much less the same. Well, actually it's actually b over 2 squared. Okay, and then the value of x here is remain because we don't have coefficient, so remain the same. And also positive 2 here also same. This one also positive. Positive 2 here also same. And then after that you have to simplify this one. So simplify, and then we'll get x minus 1 squared. Negative 1 plus 2 will be positive 1. So negative 1, 1 here. So here actually we can compare with the standard form. So this is the value of standard form. So actually the HK here, which is the minimum point, would be, okay, compare negative, negative. So the value of H is 1. And the value of K is 1 also here, okay. So this is the value of the minimum point, that is 1, 1. So we plot this minimum point 1, 1 into our graph. So why we sketch graph here? Because here we want to show the graph, the function is not one-to-one. So we use the horizontal line test. So for horizontal line test, you have to sketch the graph. So this is the graph of quadratic. So we show the minimum here is 1. Actually, the coordinate here is 1 also. 2 actually the y-intercept. Okay. And then we sketch the line y equals to k. Okay. So this is for the horizontal line test. And then don't forget to write the statement. So y equals to k intersect the graph at 2 points. So make sure you circle out the 2 intersection point there. And then after that, put the conclusion that is the function f is not one-to-one. Okay, so this is the first question, that is to show not one-to-one. And then remember after that, we have to make the function from not to 1 to be 1 to 1, and also will have an inverse. So in order to do this one, actually we have to restrict the domain. Okay, we have to restrict the domain, means that the quadratic here we have to split into two halves. So the first half is to the positive value, that is 1 infinity, and the second half of the domain would be the negative value. Okay, the negative part, that is negative infinity until 1. Okay, so remember this one actually for positive value, for positive definition, because after this you will see what I mean by positive and negative. Okay, so for this one, just bear in mind that we have two restricted domain. Okay, the first one is positive 1 infinity, and the second one is a negative one, that is negative infinity until 1. Right, so first we find the inverse for the restricted domain 1 infinity, that is for x greater or equals to 1. Okay, so in order to make easier for us to find the inverse, so instead of using the original quadratic, we will use the standard form. So remember previously we will simplify negative 1 plus 2, and it will become positive 1. Okay, so we will use this standard form. Okay, this is standard form, so we'll use this standard form to find the inverse. So remember, to find the inverse, we will use the composite function for related original function and its inverse, that is f inverse f equals to x. So using this composite function, so the composite will become the input, that is the back function. So x squared will become inverse f minus 1. Okay, this one here minus 1. We substitute here inverse f minus 1 squared plus 1. Okay, right, then we rearrange to find the inverse f. So first we bring the positive 1 to the right hand side, so it will become x minus 1. And then we know that if we bring the square to the right hand side, it would be plus minus. So there are two possibilities. So in order to determine which inverse that we use, either positive or negative, so we check the restricted domain here. So our restricted domain is 1 infinity, that is the positive one. So of course we will choose the positive. So we choose the positive square root of x minus 1. Then after that we can bring the negative 1 to the right hand side, will be 1 plus. Okay, so that's our inverse function for the first restricted domain, that is 1 infinity. So after that we will move to the next part of the question, that is after we find the inverse, so we sketch the graph of the original function. So this is the original function, the pink color one here represent the original function. So remember to put the minimum point here, so x1 and y also 1. And then don't forget to sketch the mirror plane, that is y equals to x. So this is the mirror plane. Okay, and then we sketch the inverse. So remember, the inverse will be the square root function. So we put the blue color here for inverse, and then don't forget to label the graph. So the pink one is the original function f, the blue one is the inverse, that is inverse f. Okay, and then make sure lastly make sure that the two intersection between the original and its inverse must be on the line y equals to x. Okay, so that's for the first inverse, that is for the restricted domain 1 infinity. So now we move to the second possibility of the inverse. So this time it is for the restricted domain negative infinity 1. That is x for x less or equals to 1. Okay. So the process is same. Okay, remember the process is same. The difference here is here. Remember before this we have plus minus. So in this time, since less than 1, usually we tend to use the negative definition. So the negative definition would be negative square root of x minus 1. And then lastly, we bring 1 to the right, negative 1 to the right hand side, so would be 1 minus square root of x minus 1. So this is our inverse for the second restricted domain. There is negative infinity until 1. Okay, so after we find the second inverse function for the second restricted domain, then we sketch the graph. So this is the graph for our original function. So remember, the positive one will be like this. So this is the negative one, will be like this. Okay, so also it will start at the minimum, so it move to the left and above. Okay, and then don't forget also to sketch the mirror plane, that is y equals to x, and then the inverse. So the inverse is the square root function. So the square root function, remember, positive x. Okay, inside positive x positive means the graph to the right, and then outside the set is negative. So outside set negative means the graph is to the below. So to the right and below, so the graph would be like that. Okay, so look at the blue one, to the right and to the below. So the graph would be like that. And then check the symmetry between the original f and its inverse f. So it should be symmetry to each other. So that will be our graph for the second possibility of inverse function. Alright, so I think that's all for this video. I hope you understand how to determine the two possibility of inverse function for the quadratic, so regarding its restricted domain, and how to sketch the graph between including the original and its inverse on the same plane for each cases. Okay, so until then, thank you very much. Bye bye.